Let's look at how to use the line fit equation in order to determine the concentration of our unknown sample. So this is video number 2, and we had made a graph of the absorbance at 595 nanometers versus the concentration of BSA mg per mil versus the concentration of BSA in mg per mil for our standard curve points, and we got some equations from the perfit in Excel. Let's look at what we have on our y-axis. It's the absorbance, and what we have on our x-axis, we have BSA concentration. Now, we could just take this to be protein concentration in units of mg per mil. All right. So if we rewrite our equation, we have absorbance at 595 nanometers equals the slope times the protein quantitation times the protein concentration in units of mg per mil plus the y-intercept. The y-intercept is our mathematical zero, and the slope is the correlation between the absorbance and the protein concentration. So it's really kind of, all right, what do we want to know here? What's the most important thing? What do we want to know? We want to know this. So we are going to solve our equation to tell us, the protein concentration in mg per mil is equal to the absorbance at 595 for our sample minus the y-intercept divided by, and that tells you the protein concentration in mg per mil in the SnapCap. So whatever this concentration is that we calculate, that correlates directly to the concentration of the sample in the SnapCap tube. But we're not done there, right? Because the SnapCap tube contained a dilution of our sample. The SnapCap tube contained a dilution of our snap. And so if we look at that dilution, the SnapCap tube contained a dilution of our sample. So what do we mean by that? So this is a dilute sample in here. And if we go back and we look at our experimental setup, these are all dilutions of our stock. And where are our stock concentrations? Let me highlight them in a color for you. Where are our stock concentrations? These are the stock concentrations, right? We use 60 microliters of the ion exchange fraction, 20 microliters of the gel filtration fraction. We used 10 microliters of the crude beef extract, and we used 50 microliters of the equine myoglobin sample. So we want to know what's the concentration in those stocks. So yes, right, we measured the concentration in these, right, dilutions that we made. And now we need to do some math to figure out what was the concentration in the stocks. Let's use the gel filtration example, right, to show you how to get that. So we have figured out the concentration of protein in our dilute SnapCap. But what we really want to know is the concentration of protein in the stock. This is what we want to know. So if we're using the sample as our sample, that dilution contains 20 microliters of the stock plus 180 microliters of buffer for a total of 200 microliters total volume. Okay, that's this particular stop. So this, right, is this. That's what we added 20 microliters of this. We know the protein concentration is that, and we want to figure out what is the concentration. I'm going to move the page. There we go. They've made it so generalized that it's very confusing, actually. Doesn't this make more sense when you think about it this way? And if I were even to calculate it for you, it's going to make even more sense. Check it out. Let's set up this equation with some numbers, okay? And let's say that when we solve the line equation, we found that our dilution concentration measured with the right, A equals that the dilution concentration measured as right, the concentration equals the A 595 minus the Y intercept over M. Let's say that that equals 0.6 mg per mil. All right, let's say that that is the concentration in our diluted sample. Okay, so this is the same as this. Put some numbers together, shall we? If we're using this equation here, the concentration of our dilution is 0.6 mg per mil. The total volume of our dilution is 200 microliters. Right? So we have a dilution that is 0.6 per mil concentration. That's this guy. And how much do we have? We have 200 microliters total of air dilution. That's where that number came from. When we made this dilution, we used 20 microliters of the stock. And so the volume of stock that was added to the dilution is 20 microliters. That means, right, the concentration of the stock is our unknown. So to figure out what is this, we're going to rearrange the equation so that we have the concentration of the stock is equal to the concentration of the dilution times the volume of the dilution divided by the volume of the stock. And when we do that, we have 0.6 mg per mil times 200 microliters divided by 20 microliters. And, I'll trust that you can do the math. And we're going to end up with that stock concentration being some number, right, whatever the answer is, and the units on that are going to be mg. Okay, and then you're going to use this same process to figure out the stock concentration of your column fraction, and you will use whatever the particular dilution was for that fraction. Note that it's different for gel filtration versus ion exchange. You're going to determine the same way the stock concentration of your crude lysate and the stock concentration of your myoglobin standard that was used for the Azide. We're going to do these all using the same process.